Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard. I'm joined, as usual, by Nick, founder of Postgres AI. Hey, Nick.
Hi, Michael. How are you?
I am good. How are you?
Very good.
Great. And what are we talking about this week?
Disks. If you imagine database regular icon, or how to say, like picture how we usually visualize database on various diagrams, it consists of disks, right?
Yeah, like three. Like I'm thinking of a cylinder. Sometimes a cylinder, with like normally three layers.
Yeah, C4, and obviously databases and disks, they are close to each other, right? But my first question, why do we keep calling them disks?
Like outdated term, you mean?
Yeah, obviously. Yeah. I don't know.
What does the D in SSD stand for?
Yeah, actually, sometimes we like logical level volumes, storage volumes, something like this, and in cloud context, especially EBS volumes, right? We talk about them like that, but in all cases, it's acceptable to say disks, but disks are like they don't look like disks anymore, right? They are rectangular and the microchips instead of rotational devices, right?
Yeah,
So
makes sense.
in most cases, not in all cases. Rotational devices can be still seen in the wild, but not often if we talk about OLTP databases, because it's not okay to use rotational devices if you want good latency. But yeah, so disks, because databases they require good disks and they depend on it heavily. In most cases, not in all. Sometimes it's fully cached, so we don't care if it's cached, right?
Yeah, I was going to ask you about that because I think even in the fully cached state, if we've got like a lot of writes, for example, we might still want really good disks. Like there's things where we're still writing out to disk and we want that to be fast, not just reading from.
But we are not writing to disk. If we move to the Postgres context, we don't write to the disk except a wall, right? Wall.
Yes.
Yeah, and that's it. Well, yeah, I agree. It can be expensive if a lot of data is written. So, yeah, you're right. Because we need to write our tuples, and if it's full page write after checkpoint, we need to write whole page, 8 kilobyte page. Yes, and we need to get a sync before commit is finalized. So definitely it goes to disk. But the data in terms of table and index, tables and indexes, it's written only to memory, and it's dropped for checkpoint. Normally, it dropped for checkpoint or to later write it first to page cache, and then page cache can use PD flash or something like to write it further, right, to disk. But yeah, in terms of fsync, write latency is important. It affects commit time. By the way, I just had a case, it's slightly off topic, but I published a tweet and LinkedIn post about listen notify. I added them to the list of deprecated stuff.
It's not deprecated, right? But you're saying you recommend not using it.
Yeah.
At scale.
Yeah, well,
or possibly at all.
Yes. My Postgres vision deviates from the official vision in some cases. For example, official documentation says don't set statement timeout globally because blah, blah, blah. And I don't agree with this. On OLTP, it's a good idea to set it globally to some value and override it locally when needed. And here, listen notify, I just see like we should just abandon this completely until it fully redesigned, because there is global log. And one of our customers, recall, they published great post about this because they had outages. And it's related to the topic we discussed in an interesting way. To reproduce it, I used bigger machine. And the issue is with notify at commit time, it gets a global log to serialize notify events. Global log on database, exclusive log, insane. And if commit is fast, everything is fine. But if in the same transaction you write something, commit like wall, it waits a little bit, right? In this case, contention starts because of that lock. So if you have a lot of commits which are writing something to wall, meaning they need fsync and they need to wait on disk. If disk is slow, you use notify. This doesn't scale. Performance will be terrible very soon. At like some concurrency level, you will have issues, and you will see commit spans like many milliseconds and dozens of milliseconds, and then up to seconds. And eventually, system will be down. Anyway, this is related to slow disks. You are right. If latency is bad, we might have issues.
Yeah, but you're right too that the majority of the time we care about the quality of our disks. It's when our data isn't fully in memory and we're worrying about reading things either from disk or even from the operating system. It's hard to tell from Postgres sometimes where it's coming from. But we have
it's impossible to tell in Postgres unless you have pg.k cache extension. That's why, since buffers is already in Postgres 18, again, I advertised to all people who develop some systems with Postgres, if it's possible, include extensions pg-weight sampling and pg.k cache. And kcache can show.
Yeah. I think it's not. I think you're right that it's impossible to be certain without those. But for example, through I/O timings, which another thing that people might want to consider having on, obviously a bit of overhead.
Track I/O timing, you mean?
Track I/O timing gives you an indication. Like if you're seeing not too many reads from either the disk or the operating system, and the I/O timings are bad, you've got a clue that it's coming from disk.
Yeah, indirectly we can guess.
Yeah.
That this time was spent. Yeah, not many. It's a good point because sometimes it's fully cached. In page cache, we see reads, and since there are so many of them, I/O timing is spent reading from page cache to the buffer pool, and disk is not involved. If volumes are huge, but if volumes are not huge and still a significant time is spent, very likely it's from disk.
Exactly.
Yeah.
It's not a novel. Like this is something we added to our product just as a tip. It doesn't come up that often. Like it's
enable track I/O timing.
We actually because most people don't have that on. We actually just use the buffer, like shared read, and then the total time of the operation.
It's a pity it's not on. In big systems we have it on. Like I never saw big problems on modern, at least Intel and ARM. Graviton 2 on Amazon. Like I just see it's working well. There is a utility you can check your infrastructure and understand if it's worth enabling. But my default recommendation to enable it. Of course, there might be observer effect, and it can be double checked if you want to be serious with this change. But I just see we enable it.
Yeah, it's all to do with the performance of the system clock checks and. I think, for example, the setups I've seen with really bad performance there are like dev systems that are running Postgres inside Docker and things like that still have really slow system clock lookups. But most people aren't doing that with production Postgres databases, and I haven't seen even any of the cloud providers have slow. I think it's PG test timing or something like that.
PG test timing, I double checked.
So you can run it really easily and.
But what if it's managed Postgres? You cannot run it there. In this case, you need to understand what type of instance is behind that managed Postgres instance. Take the same instance in the cloud. For example, if it's RDS, from RDS instance name, you can easily understand what EC2 instance is this, right?
Yeah.
You can install it. It will be, operational system matters also, right?
There are some there are some tricks you can do, like do things that would call the system clock a lot, like nested loop type things or count like aggregations, things like that, like trying to get lots and lots
you're
of
talking
loops
about testing at higher level, at Postgres level.
Yeah.
Oh, that's a good idea. Yeah, a lot of nest loops, and you test with this, without this, completely like running like 100 times, taking average, for example, and comparing averages, and this you can guess. Yeah, it's a good test, by the way.
I think the first time I saw that was Lucas Fittle. I think he must have done a 5 minutes of Postgres episode on this kind of thing, so I'll link that up.
Yeah, I'm glad we touched this because, again, like our default recommendation is to have it enabled. It's super helpful in persistent statements analysis and explain analysis plans, and track IO timing, if possible, should be enabled. And this is related to disks directly, of course.
Yeah.
This is, although, strictly speaking, it's not timing of disks. It's timing of reading from page cache to buffer pool. So it might include pure memory timing as well. That's why
it does.
Again,
yeah.
That's why your comment about large or not large volumes, it's important. But it's honestly like if you are a backend engineer, for example, listening to this episode, I can easily imagine in 1 month you will forget about this nuance and will think about track IO timing like only about disks, right? And it's okay because like it's really like super narrow topic to remember, to memorize. Yeah.
Well, and I guess this is moving the topic on a tiny bit, but if you're on a managed Postgres setup, which a lot of backend engineers that are working with Postgres are, you don't have control over the disks. You're probably not going to migrate provider just for quality of disks. Maybe you would, but it would have to be really bad, and you'd have to be in a setup that really was hammering them. Maybe super write heavy workload or huge data volumes that you can't afford to have enough memory for. You know, that those kinds of edge cases where you're really hammering things.
Well, there are two big areas where things can be bad. Bad means saturation, right?
Yeah,
we can saturate disk space, so to speak, out of disk space, and we can saturate disk I/O. Both happen quite often, and managed Postgres providers are not all equal, and clouds are not all equal.
Yeah,
they treat they manage disk capacities quite differently. For example, at Google, at GCP, I know regular PD SSD, quite old stuff. They have maximum 1,200 megabytes per second separately for reads, separately for write, speaking of throughput. And they have 100,000 or 120,000 IOPS maximum, right? And I know from the past discussions with Google engineers that actually real capacity is bigger, but it was not sustainable, so it was not guaranteed all the time. And they could raise the bar, but it would be not guaranteed. So they decided to choose the guaranteed bar for this.
Makes sense.
Yeah, but like basically we're not using at full possible. We could use more, right? But we cannot. So they throttle it.
Okay, interesting.
Artificially, to have guaranteed capacity for disk I/O.
Interesting. The subtlety that I was missing was not when you're at the maximum. So in between tiers, imagine you're in a much smaller setup. I see a lot of people just in upgrading to the next level up within that cloud provider to get more IOPS. You know, if you're on Aurora, just scaling up a little bit instead of switching from an Aurora to Google Cloud.
Oh yeah.
But you're right. When you're at the last or second to last level is when people start to worry, isn't it? When you're at the last level, you can't go just scale up on that cloud provider anymore. So yeah, really good point.
And also at Google, for example, it's very weird. Like I know these rules there are artificial. So this throttling, what I just told you, it also can be throttled additionally if you have not many CPUs, vCPUs. So the maximum possible throttling is achieved only if you have 32, as I remember, vCPUs or more. If it's less, also it can depend on family, I think, instance family. So complex rules. On Amazon or AWS, EBS volumes, okay, there is GP2, GP3, IO1, like you choose between them. Also, there is provisioned IOPS. Really complex, right?
But you haven't even mentioned burst IOPS yet.
Yeah. So hitting IOPS limits is really easy, actually. If you instance is
When
smaller.
do you? Yeah, well, the times I see people hitting it is like they're doing a massive migration
No,
or
not
a big
necessarily. No,
import.
they just
Okay, when do you just like just growing?
yeah, just projects just grows and then latency, database latency becomes worse. Why? We check and we see. Well, if you have experienced capabilities like to look at graphs, you can easily identify some plateau.
Yeah.
It's not full like not ideal plateau, but usually some spikes, small. But you feel, oh, we are hitting the ceiling here. You're
Well,
checking disk IO.
performance cliff.
It's not cliff. No, it's a
Mm,
wall instead of cliff. Cliff, it's when this is important distinction. Cliff is when everything was okay, and then suddenly slightly more load or something, and you completely down or down like drastically 50+%.
okay, yeah.
Here we have a wall and everything is okay, and then slightly not okay. Okay, slightly not okay. And then more is coming and we like start scheduling processing, right? Accumulating active processes. And in performance cliff, if you raise load slowly, if there is a acute drop in capabilities to process workload. In the case of hitting the ceiling in terms of saturation of disk I/O or CPU, it's different. You grow your load slowly, and then you grow further, and things become worse. It's not like acute. It's slightly more, and things become very bad only if you grow a lot further, right? So it's not acute drop. It's like hitting the wall. It feels like hitting the wall, like. If you imagine many lines in store, like for example, we have several cashiers, 8 for example, and then normally lines should be 0 or 1 people only, right? This is ideal. Throughput, everything good. We haven't saturated them. Once we saturated, we see lines are accumulating, and latency meaning how much we spend. To process each customer, they start to grow, but they don't grow acutely, boom. No. Here we talk about like performance cliff is that, for example, if we talk about cache only, no cards involved, and suddenly like we had remainings of cache for change in all lines, right? And cacher suddenly all they can like say, okay, do you have change? I have change. Okay, we're processing, and then suddenly we're out of cache to give change. This is acute performance cliff. They say, okay, we cannot work anymore. Boom. Right? We need to wait until someone goes somewhere we need 15 minutes of wait, basically. This is like important distinction of performance cliff and hitting the wall or ceiling.
Okay, I haven't heard that stricter definition before. Like it sounds to me like you're describing the difference between blackout and have you heard of a brownout? So blackout is kind of like your database can't accept writes anymore, or even selects, like no reads, like everything is down. Brownout would be like it's still working, but people are like there's spinning loaders, and it maybe loads after 30 seconds, or some people are hitting timeout, some people aren't, and there's like the queuing issue in the supermarket you talked about. Performance is severely degraded, but it's not completely offline. It's still working, at least for some people. So it feels like that's the kind of distinction you're talking about.
Yeah, and brown can become dark if you keep loading a lot.
Yeah.
If saturation happened at like some workload level, but you gave it 10x, of course it will be blackout, but because of context switching, and then it's different. But for performance cliff, it happens like very quickly. It's very much more acute situation.
I think I'm also biased by the cases that I've seen, which are more acute because they are bulk loads or backfills, where they are running at a much, much higher rate than they would normally be.
Yeah.
They're consuming IOPS at a much higher rate than they normally would. So they hit it really fast, and it's like running at the wall extremely fast. But I guess if you approach the wall slowly, it's not going to hurt quite as much.
Yeah.
Okay, I think I understand.
Yeah, back to disks. Definitely we should check disk I/O usage and saturation risks.
So you mean like monitor for it, alert when we're
Some-
close to our limits? Yeah.
Yeah, and also it might be interesting. For example, I remember, I don't know right now, but many years ago on RDS, I remember we like asked, okay, a small system maybe, we need 10,000 IOPS, but we see saturation at 2,500 somehow. And then, there is RAID actually. We have 4 disks, and that's why. Okay. So there are interesting nuances there. But also, so understanding your limits is super important. And I think clouds could do a better job explaining where the limits are. Because right now you need to do a lot of legwork to figure out what is your advertised limit. For example, as I said, at GCP you need to understand how many vCPUs. Also, disk, I forgot, like 10 terabytes, I think, is when you achieve or 1 terabyte. Memory fools me a little bit. So you need to take into account many factors to understand, our like theoretical limit is this. And then ideally you should test it to see that it can be achieved. Testing is also interesting because, of course, it depends on block size you're using, and also it depends on like you testing through page cache or direct IO, right? So directly writing to device, and then you go to the graphs and monitoring and see some disk IO in terms of IOPS and throughput, separately reads and writes, and then you think, okay, let's draw a line here. This is our limit. So what I'm saying, they should draw the line. Clouds should draw the line. They know all these damned rules, right? Which are really complex. So this should be automated. This line should be automated. Okay, with this, and this, we give you this. This is your line in terms of capabilities of your disk. And here are you. Okay, at 50%. Okay, I know. Now it's like whole day of work for someone to understand all the details, double check them, and like then correct mistakes. Even if you know all the nuances, still you return to this topic and I forgot this. Redo.
Yeah.
So, yeah.
When you mentioned the terabytes thing, is that I was working with somebody a while back who they weren't using the disk space they already had at the let's say they had a 1 terabyte disk, they only had a couple of 100 gigabytes. But they expanded their disk to a few terabytes so that they would get more provisioned IOPS, because that was the way of. So is that what you're talking about? You need a certain size. Yeah.
So the rule for throttling is so multi-factor. You need to read a lot of docs, and with GCP and AWS, I have pages which I read many times per year, like carefully trying to remember, this rule I forgot again. Why isn't this automated? Someone can say, okay, these limits depend on block size. So, okay, but if it's RDS, block size is already chosen. Postgres uses 8 kilobytes. If it's ext4, it's 4 kilobytes there. Everything is already defined. So we can talk about limits for throughput quite well, right? So yeah, this is like, I think, lack of automation here.
Also, if you mentioned the number of vCPUs, like I guess that is that they have all the setting, right? They have
all
everything.
the knowledge, and they define these rules.
Yeah.
So give me this like usage level and understanding how far from saturation I am, because it's so important. No, in reality, we wait until that plateau I mentioned, and then only then we go and do something about it and raise the bar. There should be alerts even. Your database is spending at 80+% of your capacity on disk I/O. Prepare to upgrade. add more IOPS.
Yeah, well, I was going to say, sometimes there are perverse incentives here where they're not incentivized to help you improve your performance so that you upgrade. But in this case, the incentives should be aligned. If they let you know earlier that upgrading might help prevent an issue, you're going to be paying more upfront. So the incentives are aligned.
Yeah, at the same time, these complaints we are currently expressing, they all are like reminding me complaints of a guy who is sitting on airplane and saying that there is no leg room and so on. You're sitting in the air like and flying 30,000 feet above ground, and it's magic, right? So these like ABS volumes, PDSSD, like other newer disks on GCP or NVMEs, they are great. Like, I mean, snapshots, elasticity of everything, it's great, right? We just want even more.
It's good that you're being positive about them, but I feel like I hear quite a lot of people saying that one of the cases still for self-hosting is better disks. So actually, I think a lot of the time with the cloud, you're paying for hardware that might be a bit on the older side, and you have no control over that. So I'm interested in your take on that as somebody who's historically been, pro self-managing or some hybrid version.
So I love clones and snapshots. That's why actually ABS volumes and what RDS has, and even if it's lazy load involved, and when we restore from snapshot, it's actually getting data from S3. It still feels like magic and great and like very good for reproducing incidents and so on. And snapshots are cheap because they are stored in S3. At GCP it's the same, although there is lazy load there as well, although their documentation still doesn't admit it. But just looking at the price, we understand it's the snapshots of Google Cloud disks. It's stored in GCS, so S3 analog. It's great. But also, if you think about a cluster of 3 nodes, or 4, 5, 6, up to 10 nodes and more, some people have more, database is basically copied to all replicas, and on replicas it's stored on disk, and disk become more and more expensive over time, right? So it can be significant. It can be even more than compute sometimes. That's the point. Like if we have a large database, but working set is not that large, we can have much smaller memory, thus much smaller, like not big compute instance. We had these cases, for example, a lot of time series data, and we have much bigger disk than you could expect, and then all replicas need to have the same disk, and this disk, if it's ABS volume, it becomes expensive. Very expensive, and contributes to costs so much. So then you think, why not to use local disks? Well, we used local disks for benchmarks. It was an i3 instance like years ago, 7 years ago, maybe started liking them because it's always included to price, right, of ABS or EC2 instance, and it's super fast. It's like basically one order of magnitude faster in terms of IOPS. It can give you 1 million IOPS these days already. Throughput, 3 gigabyte per second. Yeah.
Well, and the resiliency, like if you've already got replicas provisioned for failovers, you don't need the resiliency the cloud.
The point is they are ephemeral. So if restart happens, you might lose this data. But if restart happens, we have replicas. Right?
Yes, that's what I mean. That doesn't actually matter. In fact, this reminds me a lot of the planet scale stuff that's been the planet scale Postgres. I think they call it Metal. They've got 2 products, but the Metal one has the local disks, and this is a lot of the
but you can have local ephemeral NVMEs only on virtual machines, of course, smaller size. Metal.
Yeah. Sorry. All I meant was they're doing a lot of the publicity, a lot of their blog posts and things are relevant to this discussion. You don't have to use their services, and also you could do it at a much smaller scale.
Yeah, and it's so big cost saving, and it brings so much more disk I/O capacity. Amazing.
Yeah.
But there
Well,
is a
and
caveat.
latency reduction, right? Like because the systems are just closer together.
Yeah. So it's much like it can handle workloads much better in terms of OLTP workloads. There are two caveats: ephemeral property and also limits. In terms of we didn't touch disk space topic yet.
Yeah.
Yeah.
We
So,
have a whole separate episode on that, but yeah, we should still touch on it.
right. And on AWS, I like local disks much more because they are usually bigger and so on. Like they are bigger. Each disk is bigger, and the summarized aggregated disk volume is also bigger. On GCP, I think first of all somehow local disks are still I think 375 gigabytes only. Looks like old, but you can stack a lot of them, and I think up to 72 or how many
Terabytes.
Yeah, quite a lot. But in this case, you need to really like maybe go with metal, like the maximum. Take a whole machine basically, right? But it's possible. But this 72 terabytes will be your hard limit, hard stop, and it's not that bad. Like good
Most
limit.
people will be fine.
Yeah. It's okay. I mean, to have this limit. But it's a hard limit.
But the hard limit's the interesting thing. So you're saying, let's say we start on small machines and they only have a set amount, and we suddenly realize we're at 80 or 90% capacity.
Right. But at the same time, EBS volume has limit 64 terabytes, and PDSSD on GCP has the same limit, 64 terabytes. And RDS and Google Cloud SQL, they also have hard stops at 64 terabytes. Aurora has 128, double of that size, and that's it, right? So these are hard stops, and I think in 2025, I think this is not a lot of data already. 100 terabytes. We had an episode about it. It's already like achievable for bigger startups. So RDS, I don't know. I think they should solve it soon, and I think Google Cloud SQL, they should solve it soon. But to my knowledge, they haven't solved it yet. So if you approach this, it's hard stop, and basically you need to go to self-managed maybe, right? And there you can combine multiple EBS volumes.
Most that we've talked to that do this shard at that point.
This is a different route.
Point.
Yeah, that's why I think PlanScale, like, it's easier for them to choose local disks and deal with those hard limits in size as well, because just if there is a rebalancing, if it's zero downtime rebalancing, you can just make sure no shards will reach that limit. That's it. It's a good way to scale further.
They have that for MySQL, but they don't have that for Postgres. So, well, not yet. They're building it.
They announced it, right?
Yeah, well, they announced building it. I think lots of people are announcing building sharding at the moment.
Well, I see Multigrass already has some code. I even commented in a couple of places proposing some improvements.
Yeah, well, I know they all have some code, right? Like PGDog's got some code.
It's not PGDog is already. You can test it already. Yeah.
Yeah.
I think Multigrass also will have some at some point.
All I mean is that you can shard in other ways, right? Without these solutions, like Notion talked about doing it, Figma have done it.
So-called application side sharding, as I
but they did it without leaving RDS in those cases. So it is interesting, but I thought you were going to go in a different direction here. Like I thought it was more about the practicalities of expanding. So let's say you're not at the dozens of terabytes limit, whatever your provider has. Let's say you're at 1 terabyte and you just want to expand to 2 terabytes. That's often really easy. You can do it at a few clicks of a button without any downtime in a lot of providers. Whereas if you've got local disks, is it a bit more complicated?
Yeah, you know what? I think these days RDS also provides options with local NVMEs.
Wow.
I heard about this. Yeah, the instance I'm double checking right now, it's instance, for example, X2IDN. Yeah, and it has, I think it has local NVMEs, several terabytes, and up to, I think, not many actually, 4 terabytes. Interesting. So, There might be hybrid approach when you have EBS volumes and you use local NVMEs as a caching layer for both reads and writes.
But then what would you do? Would you set up some replicas with larger disks and then fail over to those? Like, how are you managing a migration to like larger local disks?
Yeah, when you hit 64 terabytes?
Well, no, let's say you've started with smaller, like you've started with local disks that are smaller.
With local disks, yeah, I think you did switchover approach, of course, yeah. So you need a different instance with bigger capacity in terms of disk space. Of course, here again, elasticity and automation of network-attached disks cloud providers have, it's great. But let's also criticize it. So they have like EBS volume has auto-scaling, but only in one direction. For example, if we reshard, right, we need to reprovision and then switch over. Or if we didn't have auto vacuum tuning in place, or we screwed up in terms of long-running transactions or abandoned logical slots, so we accumulated a lot of bloat and say we have 80% of bloat. Okay, we reindexed, repacked. Now we sit with a lot of free disk space. We don't need it during next year. Why should we pay for it, right? And shrinking is not automated. And but of course, you can provision new replica with smaller disk and then switch over. And when I think about switchover, I decided to force myself to have a mind shift and my team as well to self-driving Postgres. We talked about it, and I think when I think about this particular case, we eliminated a lot of bloat. We want disk to be smaller. We need switchover, but switchover also is a maintenance window. Yeah, because
what's the shift there? What did you used to think?
What? Say again.
What was the mindset change that you had?
So I think operations like adding disk, removing disk space when not needed, getting rid of bloat and so on, the automation must be much higher. So it should be like approval from DBA or some senior backend engineer or something, a CTO if it's small startup, just approval. Yeah, we need to shrink disk space. We don't want to pay for all of those terabytes. And automation should be very high. Repacking, and then without downtime, we have a smaller disk. But to achieve this right now, so many moving parts, and for example, you can provision node with smaller disk. It can be local, can be BS volume, doesn't matter. But then you need to switch over. Without downtime, you need a PG bouncer or PG dock layer with pause resume support. And then orchestrate it properly. RDS proxy doesn't, for example, support pause resume. So you lose. You must have some small downtime.
Yeah.
And usually people say, it's just 30 seconds. Well, I disagree. Why should we lose? This is just some routine operation. Why should we show some errors to customers? Let's raise a bar and have pure zero downtime everything, right?
Yeah.
And auto scaling, it can be auto scaling, but it can be maybe like auto scaling. It's about it makes decision itself. It's too much. Let's step back. I can make decision myself, but I want full automation, right? And we don't have it. We have it for to increase disk space, which is good for EBS volumes. Which is good. We don't need to have switchover, so it will be zero downtime. You can say add 1 terabyte. This is what people do all the time. And I think there is checkbox for auto scaling even in RDS. It can decide to add more disk space itself, right? Which is good.
Yeah, like if you get within 10%, for example. Yeah, but only up. Yeah, as you said.
Yeah, at least we will avoid downtime. I also saw in some places people there's a trick to put some file, like some gigabytes, filled with zeros. So if we are out of disk space,
so you can delete it.
We delete this file. Yeah.
Oh no.
Yeah, just like something like sitting there. We can invent some funny name for this approach. Yeah, but just emergency It's like reserved connections for max connections, 3 connections reserved for admin. So reserved disk space you can quickly delete and buy your some time to increase disk space.
Yeah. On the disk space thing, the only thing I think people sometimes get caught out by is having alerts early enough. Like sometimes you need quite a lot of spare disk space in order to save disk space. To do a repack, for example, you need the size of the table you're repacking at least 3 in order to do the operation.
With
so
indexes.
Yes. So either start with your smallest ones, which is not going to make the most difference, or like try and set that alert quite early.
Yeah.
But yeah, what is there anything else you wanted to make sure we talked about?
Yeah, well, no, I think it's a good idea to understand some numbers, right? So our very old rule was latencies. Also, we didn't talk about latencies. What latency is considered normal? Very old rule was you look at monitoring. If it's SSD, it can be best volume. If it's some best volume is also NVMe there usually these days with most like modern instance families, and you just see very rough old rule, 1 millisecond. I know I already have a feeling we have a discussion about previous episode where I shared some old rule and someone disagreed with this old rule. Yeah, rules might be already outdated. So if it's 1 millisecond, these days maybe we should go for like lower, right? Half of millisecond. If it's local disk, it should be even lower, right?
Yeah.
This is our like point when we think it's okay. If it's more, well, back those days we thought like up to like 5 to 10 milliseconds, it's okay. But these days already this is not okay. 10 milliseconds is definitely slow these days for SSDs and NVMe specifically, like particularly. So this is latency, which is like you should start worrying, right? Yeah, basically in monitoring we should control usage, saturation risks, and latency as well. This is like regular use or four golden signals, right? So we control these things and also errors. And yeah, we check all these things and understand where we are right now. And should we start worrying already? Yeah, simple. It's actually simple. And my recommendation also to know your theoretical limits based on the docs. As I said, it's not trivial. But also recommendation if you use some particular setups in cloud, always test them to understand actual limits, and if they don't match theoretical advertised limits, you should understand why. And to test it's easy. I usually prefer FIO, simple program. I like snippets GCP provides. They have snippets. If you just check SSD disk GCP performance, you will see a bunch of snippets. The only warning, I managed to destroy several times. I destroyed PG data because it was like, there are some of those snippets are direct IO, and if you try to test, like it was always not production, but still I made mistakes. And if you try to test your disk capabilities with direct IO, and you use volume which is used for PG data, forget about your PG data. And this is a good way, for example, to have silent corruption as well, because Postgres even might work for some time until you reach a point when it will touch the areas you had rights to. Yeah, so yeah, these are practical pieces of advice.
Given PG Bench stress, we've talked in the past about PG Bench stress. Is this actually a benefit in this case? Like, could we use it because it's kind of what we want to do is stress test at this point?
Right, but PG Bench tests everything, including Postgres. So if it's in our methodology,
okay.
Let's split everything to pieces and study them quite well, if possible, separately. So disk IO should be understood separately from Postgres. We had it many times, by the way. We started, let's PG Bench. Well, we talk about disk here. Let's forget about Postgres completely for now, right?
So try and isolate.
Not completely, actually. We usually keep in mind that pages are 8 kilobytes.
Yeah. Well, I was thinking on managed providers, like it's a bit like how would you test on RDS what
That's a
IOPS
tricky
you're getting?
question, right? It's a tricky question.
I think PG Bench would be a good solution there.
PG Bench, yes, but you can try to guess which instance. Well, instance is easy to guess, but which disks are there and like IOPS and so on. And then you can provision the same instance, EC2 instance and disk you guessed. And but again, as I said, one day I discovered they use a RAID. So there's a stripe there, and if you want to do the same, probably you will have different setup. That's an issue. Also with those, like I know Cloud SQL has it for bigger customers. I don't remember Enterprise Plus or something. They also have caching with local NVMEs.
Yes.
Yeah, it's good, but to reproduce it, it's already tricky to test.
Yeah.
Right. So yeah. I think I think it's tricky how to test disks for RDS. But yet another reason to think about who controls your database.
Yeah.
And why you cannot connect to your own database using SSH and see what's happening under the hood. Yeah.
Probably a good place to end it.
Yeah. Let's do it.
All right. Nice one, Nikolai. Thanks so much.
Thank you.
See you next week.
Bye-bye.